over 3 kind of tricky derivatives here using all of our various rules. Here's one where I have 3 separate terms. Whenever you are taking a derivative, you always want to first see if you can rewrite some of the terms to make things easier. I'm certainly going to rewrite this term in a times x to the b form. So that's going to be 5/6 times x to the 3/4. Now that's going to be just a power rule situation. Let me just rewrite all the other terms. They are fine as is. And now I'm just going to take the derivative piece by piece. Derivative of f of x is f prime of x. Power rule, 5/6 times 3/4. X to then I'm subtracting 1 from 3/4, so that will leave me with negative 1/4. This is an exponential term, so I have to use my exponential rule for derivatives. So it's the natural log of the base times that as it is, times the chain rule, times the derivative of the inside, which is the exponent. And last but not least, the derivative of cosine of something is negative sine, so that's going to be minus a negative sine of that. And then chain rule times the derivative of the inside of that. I'm running out of room, but that's going to be 2x minus 3, and you definitely need parentheses there. So now I'm just going to clean things up a little bit. Let's see, this is going to give me 15/24, otherwise known as 5/12, x to the negative 1/4. You could leave that as a negative exponent or bring that into the denominator. Here, just to clean this up, I usually like putting the coefficient out front. So I'll say that's 3 times the natural log of 5. It's kind of like your coefficient, times 5 to the 3x minus 1. You can use parentheses if you want. A double negative is going to give me a positive. And this order doesn't really matter. I'm just going to bring the 2x minus 3 in the front, just because it looks a little clearer to me. And there is my derivative. Whoops, that should be a 5/8. Here's another example. Here I have a product. Something times something. So I'm going to use the product rule. I can think of this first piece as A and this whole second piece as B. Product rule. So the product rule is kind of my overarching rule. In the process of doing the product rule, I'm going to have to use some other rules, like my exponent rule, my chain rule, things like that. So here I go. Product rule, remember, is just going to be A prime times B plus A times B prime. That's going to be my derivative. So A prime is the derivative of this first piece. Well, remember, the derivative of e to something is e to something. Chain rule times the derivative of that something, 12x to the 3rd. So there's A prime times B, let's do color coding, as it is, plus A as it is, times B prime, the derivative of B. So this is going to be like a big power rule, 4 times that whole shebang to the 3rd, and then times the derivative of the inside. There's the chain rule piece. Now simplifying is always a little unclear when you're in calculus. But one thing that might be nice to do to simplify this is just to do some factoring. Lots of times when I have weird, complicated things like this, I factor, just to clean it up a bit. I really have two terms. There's one term, there's a second term. So, if I want to factor out a GCF, I want to look and see what they both have. Well, they both have this e to the 3x to the 4th in common, so I can factor that out of both. This has a 12, this has a 4 times 2, or an 8. So I can factor out a 4 from both of those. I'm going to factor out a 4. And they both have 2x plus 5 to the 3rd in common. So this is a GCF. Big parentheses for the leftovers. So let's see, I took that out. I took out a 4. I took out through all of those. So in this first term, I have a 3 left. I have an x cubed left. And I have a 2x plus 5 left. Plus, in the second term, I have a 2 left. All right, and now, maybe to finish this, I might clean up the leftovers a bit. And by cleaning up the leftovers, I mean I can distribute and combine like terms. In this case, there are no like terms to combine. So this might be one way to write my final derivative. If the simplifying business confuses you, worry not. What I really want to make sure you're all comfortable with is the taking the derivative part. Let's do this next example. And again, I'm going to rewrite this before I take the derivative. I'm going to rewrite it because this notation can be a little confusing. Remember, this notation really means this whole shebang is raised to the 7th. And if you rewrite it like that, you're more likely to see that we have an inside and an outside. I have a function that's raised to the 7th. So I'm going to do a big power rule to start this. So it's going to be 7 times that whole shebang to the 6th. But I have an inside, so the chain rule kicks in, times the derivative of the inside. Well, the derivative of the tan of something is the secant squared of that something. But hold the phone, I've got an inside of my inside. So the chain rule has another chain. It's going to be times 4. Holy cow. The good thing about this is I only have one term, so there's not much to do to simplify. I'm just going to multiply together those two numbers, those two constants, 4 times 7, and get 28. And then you can, if you want, just rewrite the exponent where it often lives. And there you have your derivative.